Section 5.2, Unit Circle, Sine and Cosine Functions. In this section, you will find function values for the sine and cosine in the first quadrant, identify the domain and range of sine and cosine functions, and use reference angles to evaluate trigonometric functions. The first one, finding function values for the sine and cosine. To help us visualize our further work with trig functions, we'll be using the unit circle. Remember, x squared plus y squared is equal to 1 is very similar to a squared plus b squared is equal to c squared, which is our Pythagorean theorem. To help us remember how the trig functions work, we will also use the mnemonic SOHCAHTOA. SOHCAHTOA means S is sine, O is opposite, H hypotenuse, then cosine adjacent, hypotenuse, then tangent, opposite, and adjacent. Cosine of t is x and sine of t is equal to y, and this is angle t here. So the xy coordinates is equal to cosine t sine t. If we have here this triangle here, and this is our angle t, and if we want to find sine of t, that is based on our SOHCAHTOA, its sine is opposite over hypotenuse, meaning this is the opposite side, and this is the adjacent side, and this is the hypotenuse. So we know that sine is opposite over hypotenuse, and this side here is the y side over 1, so which is equal to y over 1, or just simply equal to y. So that's why sine t here is equal to y. Okay, let's try example 1. Find cosine t and sine t for the following points. So let's start with cosine t. Based on our SOHCAHTOA, so this is angle t adjacent over hypotenuse, and this is our adjacent, and this length is 1/2 over the hypotenuse 1, so cosine of t is equal to 1/2. Next is sine of t. We know that it is opposite over hypotenuse, so the opposite is this, and the length of this is square root of 3 over 2 over hypotenuse 1, so sine of t is square root of 3 over 2. So that's why you will see here that cosine of t is the x value, which is this one, 1/2, and sine of t is the y value, which is square root of 3 over 2 here. So based on this, on the right, we have here negative square root of 2 over 2 and square root of 2 over 2. This is your x and this is your y. So you can say that this is angle t, cosine of t here is equal to negative square root of 2 over 2, and sine of t is equal to square root of 2 over 2. Example 2, letter A, find cosine 90 and sine 90 degrees. So this is 90 degrees, and in a unit circle, 90 degrees, the coordinate is 0, 1. This is your x and this is your y. So you can say that cosine of 90 is equal to the x value, which is 0, and sine of 90 is the y value, which is equal to 1. Next is find cosine pi and sine pi. Where is pi? This is pi, and this point coordinates, we have negative 1, 0, and this is our x and this is your y. So you can say that cosine of pi is equal to, yes, the x value negative 1, and sine of pi is the y value, which is 0. So just to recall, always remember that xy, x is cosine and y is sine. Okay, next is using the Pythagorean identity, and it says that for any real number, cosine squared t plus sine squared t is equal to 1. So remember Pythagorean theorem, x squared plus y squared is equal to 1. Since cosine is x, sine is y, so x squared plus y squared is equal to 1. Why is this true? Because cosine of t squared is equal to x squared, and also sine of t squared is equal to y squared. That is from the unit circle. Notation abuse: whenever you see cosine squared of t, that is the same thing as cosine of t squared. Also, sine squared of t is the same thing as sine of t squared. Example 3. If cosine t is equal to 24 over 25 and t is in the fourth quadrant, find sine of t. Cosine of t is in the fourth quadrant. So let's say this is the fourth quadrant. We want this angle. So we have, remember, cosine squared t plus sine squared of t is equal to 1. Cosine is 24 over 25 squared plus sine squared of t is equal to 1. And if we subtract 24 over 25 squared, we will have sine squared of t is equal to 1 minus 24 over 25 squared, and if you get the square root both sides, you will have sine of t is equal to square root of 49 over 625, and sine of t is plus or minus 7 over square root of 625 is 25. And since it's in the fourth quadrant, so it's gonna be sine, meaning the y value is negative. So negative 7 over 25. Sorry, I used this space. Alright, example 4. If sine of t is equal to 3/7 and t is in the second quadrant, find cosine of t. So this time it's in the second quadrant. So we want to find cosine of t. So let's say this is your angle t. So let's use again a Pythagorean identity. Cosine squared t plus sine squared t is equal to 1. Sine t is 3/7 squared so that is 3/7 squared is 9 over 49 is equal to 1, and then subtract 9 over 49, so 1 minus 9 over 49, and then square root cosine of t is equal to 49 minus 9 is 40 over 49. So cosine of t is plus or minus square root of 40, and the square root of 49 is 7. And since it's in quadrant 2, cosine, which is the x value, in quadrant 2 x is negative, y is positive, so cosine is negative, so the answer is cosine of t is equal to negative square root of 40 over 7. Okay. Next one, finding cosine and sine of special angles in the first quadrant. Remember that we put a lot of work to recognize the 3 special angles in the first quadrant in the last section's notes. And they were 30 degrees, which is in radians is pi over 6. Also 45 degrees, that's equivalent to pi over 4, and 60 degrees, that is pi over 3. Luckily, these special angles all have easy to remember sines and cosines that come from special triangles. This is 30 degrees, and we have the coordinates square root of 3 over 2 and 1/2. This is your x, y, so meaning this is your cosine and this is your sine, and we can say that cosine of 30 degrees is equal to square root of 3 over 2, which is also the same thing as cosine of 30 degrees is in radians is pi over 6. Same thing, we can say that sine of 30 degrees is the y value, which is equal to 1/2, and that is the same thing as sine of pi over 6. Then 45 degrees, so this is cosine and sine. Cosine of 45 or cosine of pi over 4 is square root of 2 over 2. Same thing with sine of 45 degrees and pi over 4. Then 60 degrees is 1/2 and square root of 3 over 2. All these special angles have easy to remember sines and cosines as from special triangles. Remember 30, 60, 90. And the 45, 45, 90 degree triangle. And that is all with hypotenuse of 1. So always remember, if you have the unit circle, this is 30 degrees, and that is, we have square root of 3 over 2 and 1/2. This is 45 degree angle. This is like the 45, 90 with the hypotenuse 1, and we have here square root of 2 over 2 and square root of 2 over 2, and this is the 60 degrees, so meaning this triangle is a 60, 30, 90, and we have here 1/2 and square root of 3 over 2. This is 30 degree. So to summarize, and please remember this, 0, this is a unit circle, this is 1, 0. 30 degrees cosine is the x, square root of 3 over 2, and the y is 1/2. 45 degrees or 4 or pi over 4 is square root of 2 over 2 and square root of 2 over 2, and then 60 degrees or pi over 3 is 1/2 and square root of 3 over 2, and 90 degrees, which is 0 and 1 as your cosine and sine. Okay, so it's very important to remember the first quadrant. Next one, identifying domain and range of sine and cosine functions. Since f of t is equal to sine of t and g of t is equal to cosine of t are defined by the unit circle, we know their domain and range are from negative infinity to positive infinity for to main, and since it's a unit circle, it is from -1 to +1. Inputs, that is the t, which is the angle. So just like, for example, this angle here. So those are the inputs, and the outputs are the y coordinates. That is on the unit circle. Alright, next one, finding the reference angles. That is opening up the entire unit circle. If we only look at angles in the first quadrant, but of course we want to be able to find the sine and cosine of angles in any quadrant. So luckily, all we need to know is the first quadrant, then use the reference angles to get any angle back to the first quadrant. So for any angle t, you find its reference angle by finding the same angle in the first quadrant. Again, the reference angle is by finding the same angle in the first quadrant. So example number 5, find the reference angle of 225. So if we sketch and show where 225 angle is, this is 225. So from here to here is 225. So what is the reference angle? And the easiest way to do that is finding the fastest way to the x-axis. So fastest way to the x-axis from here to here is, this is 180. So you could use 225 minus 180 is equal to 45 degrees. So if this is 45 degrees, then the fastest way to the x-axis, the reference angle, is 45 degrees. Letter B, find the reference angle of 5 pi over 3. Where is 5 pi over 3? Is here. So that is 5 pi over 3. The fastest way to the x-axis is this part, and that this is 2 pi. So 2 pi minus 5 pi over 3. 3 times 2 is 6, minus 5 is 6 minus 5 is pi over 3. So this is pi over 3, and this is the reference angle, which is pi over 3. Okay, letter A, example 6, find the reference angle of 30 degrees. So again, where is 30 degrees? This is 30 degrees. And again, reference angle is the same angle in the first quadrant. So 30 degrees is already in the first quadrant, so the reference angle is just 30 degrees. Letter C, find the reference angle of negative 5 pi over 6. Where is negative 5 pi over 6? This is negative 5 pi over 6. fastest way to the x-axis is this angle, and this angle is like pi over 6. So the reference angle, if this is pi over 6, this is also pi over 6. That is the angle in the first quadrant. So the reference angle is pi over 6. So always remember, what I did here is finding the fastest way to the x-axis. So let's say letter C here, negative 5 pi over 6. The fastest way to the x-axis is this part here, and this angle is pi over 6. And same thing on the first quadrant. That's why we have here pi over 6. Example 7, using the reference angle, find the exact value of 150 degrees and cosine 150 degrees and sine 150 degrees. $150 degrees is this angle. So this is 150. So this is in quadrant 2, and we know in quadrant 2 we have negative and positive. This is your cosine and this is your sine. And reference angle, fastest way to the x-axis is this part, and this angle here, if this is 150, so meaning this is 30 degrees, right? So we can say that cosine of 150 degrees is equal to cosine of 30 degrees. But since it's in quadrant 2, cosine is negative, so this is going to be negative. That's why here cosine of 30 degrees is negative square root of 3 over 2. For sine of 150 degrees, so this is 30 degrees, so it's the same as sine of 30, and in quadrant 2 sine is positive, so that's why it's positive, and this is equal to positive 1/2. Okay, I'll let you try to work on letter B for cosine 5 pi over 4 and sine 5 pi over 4. Then for example 8, I'll let you also try to work on letter A, cosine 315 and sine 315. And I'll show you letter B, find cosine of negative pi over 6 and sine of negative pi over 6. Sketch a unit circle here where is negative 5 pi over 6. So this is negative pi over 6, and this is in quadrant 4, meaning you have positive and negative, and here you have square root of 3 over 2 and negative 1/2. Okay, so cosine of negative pi over 6, reference angle, fastest way to the x-axis, this is negative pi over 6, so this is the reference angle, which is pi over 6, so this is equal to cosine of pi over 6. In quadrant 4, cosine is positive, and that is equivalent to square root of 3 over 2. Then sine of negative pi over 6, reference angle is sine of pi over 6, and sine in quadrant 4 is negative, so this is negative. That's why this is equal to negative 1/2. Okay. Next, our goal is to complete this unit circle. And remember this, all students take calculus, meaning we have A, S, T, and C in quadrant 1. This is all is positive. S in quadrant 2, meaning sine is positive, and in quadrant 3, T, and here tangent is positive, and in quadrant 4, the letter C, which is where cosine is positive. So look at this, all meaning everything here is positive. For sine, meaning the y values are positive, and the cosine here negative. Tangent is positive. Tangent is sine over cosine, or y over x, meaning negative over negative is positive. And in quadrant 4, cosine is positive and sine is negative. So always remember to plot your points, then know the reference angle from quadrant 1. This is quadrant 1. And know where sine and cosine are, positive and negative. Okay? Alright, let's have some lecture questions. So again, stated the domain and range of the sine and cosine functions, and explain why these are so using the unit circle. So domain, you know that is from negative infinity to positive infinity, meaning angles can be any number. Then range is, yes, from -1 to +1. In a unit circle, that means the biggest it can be is positive or -1. So that's why. Next, for the following exercises, find the reference angle. Whoops. Of A, B, and C. So letter A, 100 degrees. Now let's locate where 100 degrees is. So this is 90, so let's say this is 100 degrees. And fastest way to the x-axis is this. So that's why it's 180 minus 100 is equal to 80 degrees. 80 degrees. So that is letter A. Letter B, -315. So I'm gonna use it here. Where is -315? And so this is -315 degrees. Fastest way to the x-axis is this, and that is 360 minus 315 is equal to 45 degrees. So this is 45 degrees. So which is the reference angle of letter B? Letter C is negative 11 pi over 3. Where is negative 11 pi over 3? It's somewhere here. So that's negative 11 pi over 3. So fastest way to the x-axis so that is like 4 pi minus 11 pi over 3. 3 times 4 is 12 minus 11 is equal to pi over 3. So this is pi over 3. And that is the reference angle. Okay. And the last one, complete the first and the second quadrant of this unit circle. Write the degree measure and in the dashed line, the radian measure in the solid line, and the coordinate pairs. So let's start with 0. This is also 2 pi, which is equal to 360 degrees. The coordinates 1, 0. So quadrant 1, we know that this is 30 degrees, which is the same thing as pi over 6. This is 45 degrees, which is pi over 4. This is 60 degrees, which is pi over 3. This is 90 degrees, which is pi over 2. And the coordinates, remember, we have here square root of 3 over 2 and 1/2. This is square root of 2 over 2 and the square root of 2 over 2. This is 1/2 and square root of 3 over 2. And this is 0, 1. If we continue here, since this is 90 and pi over 2, so this is 120 and 2 pi over 3. Next one, we have 135 and 3 pi over 4. Next one, we have 150 and 5 pi over 6. And this one is 180 degrees and pi. The coordinates, since we know that this is quadrant 1 and both are positive, and in quadrant 2 we have here negative and positive, you can just copy this. This is going to be negative 1/2 and positive square root of 3 over 2. This one negative square root of 2 over 2 and positive square root of 2 over 2. Next is negative square root of 3 over 2 and positive 1/2. And here negative 1, 0. Okay, that's the first and the second quadrant of the unit circle. And that is section 5.2. Let me know if you have any questions. Thank you.